break that we had. I was actually pretty good for a couple days, but then that stopped happening like last night. So hopefully be able to get through most of this stuff today. I will have your grades updated for the exams and all that sort of stuff. Plan on doing it later today. So some of the stuff in this chapter, it, it's going to be a bit of a rehash of other things that we've actually covered so far. I would like it a lot better if a lot of this stuff that we had to do in here was just do it all at once instead of, hey, let's introduce it now and then come back to it 3 times later. But that's how the book is, and the book is free. So I'm not going to worry about it too much. Need to get a copy of the Excel open as well as my graphing calculator. So just looking at what we have here, dimensional analysis. So you can see here that we actually covered it a little bit in 2.4. And now all of a sudden we're going to be doing it again in 3.1. Drawing of a scatter plot, blah, blah, blah. So how did you all do with the conversions here on the exam that you had? Anyone willing to admit that they ended up going to Google and typing in 1,100 yards to feet just to see what it was saying? So no one's going to admit that, and it's going to look like, no, I didn't do anything. Yeah, some of these can be a bit are pretty stupid, like here, 32 hours to seconds. Um, but some of the with some of these things though, when you actually look at the changes there, it's like, how long is 1,000,000 seconds versus 1 billion seconds? And when you think about stuff like that, your first thought is usually going to be what? Why are we talking about this in seconds? Why not minutes? Why not hours? Why not days? Why not weeks? Why not something that's more useful and relevant? So, a couple of problems here. Rewrite each fraction with the given denominator. So if we're looking at, I'm looking to do a couple of these because the basic idea here is actually fairly easy to think about. It's just most of the time for students when they're looking at these, they tend to freak out because we're dealing with fractions and you remember the horrors of trying to add and subtract fractions. And what happens when you're trying to add and subtract fractions? What's the goal there? To get the same common denominator. Right now, I'm teaching an Algebra 2 class up at Saginaw Valley, and uh, a lot of the problems we have in there are quite literally, let's find the common denominator of this fraction, and then going through and trying to figure out, okay, if we know what we're doing, how would we do this? If we don't see it instantly, how do we do this? How can we make it as easy on ourselves as possible at the beginning versus um, how can we make it extremely difficult on ourselves? So looking at the first fraction that we have here, we have 5 over 3. We need to turn that into 21 over what's going to end up being some number. Now, when we're trying to do something like this, if we're trying to find that common denominator, I don't know if this is going to help at all, but a lot of times what we're going to end up doing is multiplying the denominator by a certain value to make it what we want. And then once we multiply the denominator by that value, we then have to go in and multiply the numerator by that same value. So 3 times what gives you 21? I have to admit that my sinuses are clogged too, so I can barely hear anything. 3 times what gives me a 21? 7. So this is going to be the same as saying 5 times 7 over 3 times 7. 3 times 7 is 21. 5 times 7, and you obviously all remember your multiples of 7s, right? Because you deal with 7s all day long, right? So this is actually going to be the 35. With C, we've got 14 over 4, and we need that to be equal to 10 over something. So again, we can multiply the denominator by a certain value. 4 times what will give me 10? If you say 4 times 2, you get 8. 4 times 3, you get 12. We want the number that's in between there. So what's in between 3 and 4? Or, sorry, 2 and 3? 2.5. So what we end up doing here, multiplying top and bottom by 2.5. And did the graphing calculator even open? Or did it just give me a warning to say, oh, you didn't renew your license, so you suck? Excellent. It's telling me that my free thing has expired. So if you don't know what that is right off the top, we can say 14 times 2.5, and we get 35. So some of the stuff that we just did here is kind of useful, especially if we're going to be dealing with fractions and say you're dealing with the online homework system, where say if you're dealing with fractions, it wants the answers in fractions, not decimals. So looking here, number 3, it says draw a scatter plot for the data provided, which are global sales in millions for each of Metallica's first 9 albums as of January 1st, 2016. Album number 1, 2, blah, 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 blah. And then the number of albums that were sold for each one of them. If we're going to be doing something like this with a graphing calculator, uh, we have to determine which one of these, and these are going to be called variables. So which one of these variables do we want to be the x-axis? Which one of these variables do we want to be the y-axis? So album number, because they probably want to show the rise and fall of album sales for Metallica based on where they're at. So album number is probably going to be our x variable, and sales is going to be our y. So if we're going to do this with the graphing calculator, I'll clear that out. I need to go to start, and then to edit. And while you guys were taking your exam and on break, my students up at Saginaw Valley were actually still using the calculator. So there might be a whole lot of stuff in the L1 and L2 columns. So to get rid of that, you can highlight L1 and then hit the clear button. So with this, we want 1, 2, 3, 4, 5, 6, 7, 8, 9. Over here, 5.5, 7.1, 7.8, 9 million, 23 million, and then 8.5, 7, 4.3, then 2.3. So now that we've got that, if we actually want to make a scatter plot with the data that we have here, uh, just because, like I said, my students in my other class have been using these calculators, there's probably going to be functions in here. If you go and hit the Y button or Y equals button, you can see here that I've actually got a function in there from my other class. So I need to clear that out. If you have other functions in there from where you were doing this, you can clear all those out. And then I need to go to second and then Y equals. And the first thing that you're going to see on the top here is basically where it says stats plot or plot one off. We want to turn plot one on. So I need to hit the enter button and you can see how it's blinking on the on, hit enter. L1 is going to be my X list of L2 is my Y list. And then up here, I get to try to determine which one of these types of graphs do I actually want to use. For a scatter plot, it's traditionally been just a bunch of dots on a background. So that would actually be the first thing. So the way that I've got it set up right now, I can hit enter to say I want that type of plot. Then I should be able to go to where it says graph and we see some things. But uh, looking at the graph the way that it is, uh, this goes from -10 to +10 for Y. We do have this one album here that's at 23 million. So that's not actually going to be showing on the screen. Yeah.
My my calculator is like blank. It's been like that for a while. I think maybe the axis has been like messed up, like we're doing nothing.
Looking at that, it's pretty cheap.
Do you know how to fix it?
Well, I was going to show you how to make this graph look a whole lot better. So follow along. So because everything is in what we call the first quadrant up here, I can actually go to window. And you can see here that I have X min equals -10. What is the minimum number of album sales that someone can have? 0. So let's make X min 0. And if we're thinking about the x-axis, what is that actually? It's uh, how many albums do they have, or what album are we looking at, right? So can anyone have negative albums that have been released? You can have an album that gets really negative reviews, but can you have an album that was released 5 albums before your first album? No. So we can make that x equal to 0, or x min equal to 0, x max equal to 10, y min, make that equal to 0. Since we know that the highest value we have in this graph is 23, a good place to have, say, the maximum value here, probably be like 25. Once I make those changes, now we can actually see kind of what's going on here. So they started off low, they got high, and then some album was really popular. And then the next one wasn't as popular, and people didn't buy the next couple albums after that. And when you look at a lot of the artists, when they're looking at record sales and stuff like that, a lot of times you'll see that sort of thing. Uh, with a lot of artists, there's, say, one album that is really, really, really popular and sells a whole lot. And then all the other albums are basically filler and a reason for that artist to go out on tour just so they can play a lot of the hits off of that one album that everybody really loved. And no, that's not being cynical, that's being truthful. Um, so we come over here and we look at the answer for this. You can see how that was made. If we're going to do this in Microsoft Excel, I can actually type in things here and make it look a lot more like what we have here. I can say album number, sales, and then do 2, 3. And because Excel has the ability to kind of figure out what the heck it is I'm trying to do here, I don't even need to put in all the numbers. Just having those numbers in there, I can drag this down. So got it down to the first 9. Unfortunately, because of the way the textbook is, I can't copy the data and do stuff like that, which is kind of annoying, which means I have to go back and plug in all of these numbers. So there we have all of that. Now, if I want to make the scatter plot, I will highlight both of these. I also want to make sure that my x variable, whatever I want my x variable to be, it's going to be on the left side. My y variable should be on the right side. I can go to insert. Then down here, I've got charts. So we can kind of see what some of these different charts look like. If we just want the traditional scatter plot, it's going to be nothing but dots like that. We can try to make it where it connects all the dots using, like it says on there, smooth lines and markers. Or it can come down here where we make everything have straight lines and markers. Depending on what it is you're trying to do, a lot of times, say straight lines is going to be a better thing because I'll just use the straight line thing here so you can see what I'm talking about. Because these are album numbers, uh, there really isn't any sales in between here, but we know that from this album to this album, the number of sales actually did go up. So having the line that looks like that actually is beneficial. And if you want to try to, if you have like unlimited black ink on your printers at home and you want to do something cool, I actually think that looks kind of better, doesn't it? It's quite a bit different, depending on who it is you're trying to impress and all that sort of stuff. Using something like that or using something like that might be a little bit better option. Whereas if we go back and we look at the curved lines here, this is kind of showing that from album 1 to 2, it's a fairly straight line, 2 to 3, a fairly straight line. Then somehow between album 3 and 4, sales take a dip. There are no sales, but the line that we have here actually makes it look like it's taking a dip. Uh, this is something that's actually pretty commonly used, but nothing that we really need to worry about in here. If you look at what's on the screen here as well, I can click on the plus that's up here. I can create axis titles. So I can actually come in here and make it so that this says, so like sales million, and I did not mean to do any of that. Let's try that over again. And down here, come on, should be able to highlight all of this. Say album number so we know. kind of what it is we're looking at and we're trying to deal with. That just makes it look a little bit more professional. So if you're going to be doing graphs or charts or something like that for another class, a handy little trick, and it's all with this plus thing up here. If you needed to, you could put in a legend. There'll be times when we can have multiple, say, sales figures on the same graph. Having legend in there is really important for that. You can also put in data labels, but when we're looking at all of these points, what are we supposed to be getting from this? This line right here is 5. This is below 5. So it's about 4 million sales. This is almost 4.3. Do we really need to have the data points on there? Again, that's 5, that's 0, that's kind of in the middle. What's happening between 0 and 5? 2.5. So do we need that information? Maybe, maybe not. But those are all things that you can actually do with Excel. So looking at here about how many hours daily could I expect on my birthday, which is July 8th. That's the author's birthday. So that's about where July is at. So looking at the graph, what would you have to guess? If this was a problem that was on the exam, where would you guess that point is? We know that's 12. You know the line on the top is 16. Would you call that 15 or say 15 and a half? So here it's in about 15 hours. About when does daylight time get longer than 12 hours in the spring? Um, so we all know about spring, right? When does spring start? Well, no, it starts in March. So looking at March and then April. So somewhere between like a March and April on the day when you get exactly 12 hours of daylight and 12 hours of dark. Anybody know what that day is called? The equinoxes and there are all sorts of other stuff like that. Um, sorry, I can't really think about what the name of it is right now, but like March 22nd, March 23rd. And then over here, basically like September 23rd is when we're going to have the next 12-hour day. Looking at the graph here too, when you look at it in January, you get about 8 hours of sunlight per day. By March, you're all the way up to about 11, which is why the sunlight seems to be getting brighter in the morning and staying lighter later into the day. So, all right, so interpret rate of change, predict future values from rate of change, calculate a rate of change, find the intercepts of a line, interpret the meaning of intercepts of a line. Yeah. So some of the stuff that we have in here, and you can see some of the questions that are coming up here. If you make $100 a day for doing a certain job, how much money would you make in a 5-day work? So here's where we use a little bit with all the rates and everything that we're going to be talking about in here. We're going to be using that dimensional analysis thing. And we're told here that you make $100 per day. And we're asked if you work for 5 days, how much money are you going to make? And much like all that stuff that you all hated about dealing with fractions, I've got day on top, I've got day on the bottom. So those are going to cancel out. So according to this, if I work 5 days. I'm gonna make 5 times $100, so $500. Looking here, says a rate of fraction equivalent to 60 miles in 4 hours. That has 2 in the denominator. What number do I have to multiply 4 by to get 2? Or what value do I have to multiply 2 by to get 4? So if I have to multiply 2 by 2 to get 4, that means I have to multiply these two numbers by 1 over 2. So where does that come from? Well, looking back at what we had here in here, same type of idea. This is saying 60 miles in 4 hours is equal to some number of miles in 2 hours. And you already told me that this is going to be a 2 and a 2. Since I'm multiplying by 2 over here, when I bring it to the other side, what do I have to do? Divide by 2, right? Because literally what we have down here is that we know that that's going to be a 2. So if I want it to be in units of 2 hours, I have to divide both sides by 2. And is that a bit tricky? Yeah. So what we're actually going to be doing here is multiplying numerator and denominator by 1/2. 60 divided by 2, it's going to be 30. 4 divided by 2, it's going to be 2. And the units here are miles per hour. And here it says write a fraction equivalent to $320 in 4 days that has a 10 in the denominator. How do we go from 4 to 10? We multiply 4 by what value? 2.5. So multiplies the numerator by 2.5. And looking at some of the data like we have here. So it says that most experienced runners get to a point where they can comfortably jog long distances at a constant pace. This pace, of course, is another way to say rate of change, because speed is the rate at which distance changes compared to time. That's why it's called miles per hour or meters per second or feet per second or whatever we want to call it. So looking at what we have here, it says the rate at which distance changes compared to time. One particular runner jogs 1 lap around a 400-meter track in 2 minutes. So assume that the runner can maintain this pace for a long time. Then here it says for every blank minutes, the runner jogs blank meters. So with this one, we're looking at 400 meters per 2 minutes. Once we have that, what they actually want us to do here is try to reduce that. 400 on top, 2 on the bottom, even number and an even number, right? So I can pull a 2 out of here, I can pull a 2 out of here. What's 400 divided by 2? So this person can run or jog at 200 meters per minute. So where it says for every one or for every blank minutes. So for every 1 minute, the runner jogs 200 meters. Looking at the table that we've got here, we see that at 2 minutes they've ran 400 meters in 4 minutes. So going from 2 minutes to 4 minutes, what happens there? How do you get that value? 2 times what gives me 4? 2. So if I can look at this. So a couple different ways we can answer this. If I look at this and look at this is double the time. So we should have double the distance, assuming that they're running or jogging at the same pace. So what's 400 times 2? 800. If we build this up again to say 6 minutes, um, how far will they have gone? So if we've got, so 2 minutes, 400 meters, 4 minutes, 800 meters, in 6 minutes, we can actually look at this a couple different ways. If I add 2 minutes on here, I add 400 meters on here. So if I add another 2 minutes on here, I add another 400 meters on here. Does that make sense? So to get the value that would be here, we can either look at that and say, well, there's a 2-minute gap here. So however fast they went in 2 minutes, we add that. So another 2-minute gap. So we're going to add another 2 minutes. There are 400 meters on there. And then we can continue to do this. If I give you something screwbally, like say 9, do we have any reference that we can actually use here? This gap is 2 minutes, this gap is 2 minutes, this gap is 3 minutes. So we're kind of stuck. But what we can do is we can actually create a function. Show you how to do this in Excel in a moment, where we're going to look at, we can do this in a graphing calculator as well. We know that this person runs about 200 meters per minute. So I can look at this minutes column here and basically come up with the meters that this person ran is equal to the number of minutes that they're running times what I've got here. So now if I'm going to use that, 9 minutes, 9 times 200. If I give you something really screwbally here and do like say 18.37, what do I do? They run for 18.37 minutes. Put 18.37 in here, multiply that by 200, and we're done. Now, let's say you're looking at this and we're talking about how fast do they run? I've got that number right here. 400 meters in 2 minutes, we can reduce that. What happens if you don't see that instantly, or you don't recognize that you can make that particular change? What's going to happen? Well, we can still come up here, use the same thing. But this time I'm going to say 400 meters per 2 minutes. And I'm going to get exactly the same results. Okay. So if we go to Excel real quick, uh, anything here, do need to make it quite that big, but well. So we've got minutes versus distance. We're going to say distance 1 and then distance 2. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we could even do 18.37 if we really, really wanted to. So what I said was we can use uh, our formulas here. So the number of minutes times Excel won't let you do anything with the units, so we have to come in here and just say times 200 and be done with it. And we'll drag this down. 2 minutes, we've got 400 meters. At 4 minutes, we've got 800 meters, which is what we are predicting. And again, if we don't see that we can take that and reduce it to that, we can still go in, we can still use the exact same numbers that we have. Oops. So that'll be times 400 divided by 2. And then hit enter. Same thing. And notice that we get exactly the same answer here. I can take this, I can drag it all the way down. We can see that we get the same answer all the way through, which is kind of convenient, right? So if you know what you're doing, you can do it one way. If you get scared, if there's something on the exam, and let's say instead of 400 meters in 2 minutes, you get, say, 189 meters in 1.76 minutes. You can do the same thing. It's not going to be an issue. If we want to try to do this with our graphing calculator, again, if we're going to be filling out a table, we're going to want to go to Stat and then go over to Edit. And I need to get all this stuff cleared out of here. So let's say 1, 2, 3, 4, 5, 6, 7, 8, or 7 and then 8. Now let's do 9. Now over here, highlighting L2, what do I need to say? I need to go seconds and then 1 to get me L1 times. And let's say we're actually going to be using this value up here instead of the numbers we've already calculated. Because this is a straight fraction, I can say 189 divided by 1.76. Hit enter. And that's how many meters this person ran in 2 minutes, 3 minutes, 4 minutes, and so on. Oops. So do this again. I've got my numbers in there. So again, highlighting the L2, it's seconds and 1 to make it say L1 times the number I have on top, 189 divided by the number I have on bottom, 176. And there we go. It's in days like these when I really wish I remembered to bring nose paper instead of having to grab toilet paper. So we've got a couple different ways that we can try to answer these problems. It's not going to be that big of an issue. Um, so once we have that, though, we can start getting into questions like here. It says, what would the runner's total time be for a 10K race? 10K race means what? The K stands for thousand. So 10,000, 10,000 what? 10,000 meters or 10 kilometers. So if we're using the numbers that we have here, what we need to do, and this is because everyone so totally remembers all their algebra skills, right? So totally. So again, without trying to be too tricky or anything like that, we know they do 400 meters in 2 minutes. And what we need here is 10K. So this is going to be in basically X number of minutes. So this is also going to be, we can write it out as 10,000 basically, or meters divided by minutes. This came straight from the problem. We're given the problem of this person is going to run a 10K. How long will it take him to finish it? Notice that meters are on top, minutes are on the bottom. So we can do some fancy stuff here. Or what's the number that I need here? X, right? So a couple options here. I can cross multiply and just multiply across over here. If I do that, I get X minutes equals 10,000 meters times 2 minutes divided by 400 meters. I'll multiply across, so that's going to be 20,000 kilometer minute, or sorry, meter minutes divided by 400. That zero can cancel out there. That zero can cancel out there. 200 divided by 4. Um, and up here, we've got meters. Down here, we've got meters. So we would expect them, sorry, to finish in about 15 minutes. How do we want to make can we make this easier on ourselves? Yes or yes. So another thing we can do is take these and just basically flip it over and flip both sides. Now I want to get X minutes all by itself. That just means I have to multiply across over here, which basically gives me that same thing up there. So instead of trying to do, uh, remember to flip these two things around and multiply this over here, we can actually flip both things upside down and basically be done with it. Yes, right. So either one of those will actually work. They end up being exactly the same thing. And then looking at what we have here. So it says here, according to taxifarefinder.com, a cab ride from the airport in Las Vegas will cost you an initial charge of 510 plus 260 per mile. Use this information to fill the rest of the table, describing the total cost for various distances. Then create a scatter diagram using the distance as an x coordinate and cost as a y coordinate. So we've got all this stuff down here. So just looking at what we have here and thinking about what they were actually just trying to tell us, they said that cost was equal to, what was it, $2.60 per mile times X number of miles plus $5.10 initial cost. So to call them up, have the driver come out and then cancel it. It's going to cost you $5.10. And if you look at the table that we have down here, you can actually see that. So if you're, so what's the rule that we should use if we're going to do something like this? Make sure that you actually know that you want to go somewhere before you call them up to have them come pick you up. Anyone here ever used rideshare services? Or anyone here ever be a driver for rideshare services? My brother was for a while, and um, he would he'd get people that would call for a Uber or whatever, and then he'd get say he'd agree to it, get halfway there, and then they would cancel on him. And at one point, they wouldn't give him any money at all, even though he drove halfway there. So having that little fee there, that's to kind of compensate the driver for their time. So looking at the other questions that we have here, it says, what do you notice about the pattern? Well, this formula, when we plot it out, is going to look like y equals mx plus b. What type of a plot does y equals mx plus b actually give us? It's an equation of what? A line, right? And what's going to happen here is for every additional mile that we have or that we take, it's going to cost an extra $2.60. So if we want to go 10 miles versus 12 miles, what's the difference in price going to be between 10 miles and 12 miles? Well, it's $2.60 per mile. What's the difference between 10 miles and 12 miles? 2. So 2 times 260, so it's going to be an extra 520. Or looking at the question that's on here, it says what's the how much more will you pay for a 3 mile ride than a 2 mile ride? What's the difference between those two distances? 1. So 1 times 260. Um, so with all this, we're assuming that you've already gotten in the path. Okay. So big assumption there. And here it says, how will you pay for or how much more will you pay for a 5 mile ride than a 2 mile ride? Again, what's the difference between these? 5 minus 2 is 3. 3 extra miles times 260 per mile. So it's going to be what, 780, something like that. So we got slope of a line here. Uh, so the difference of coordinates, and this is where the rise over run thing comes from. change in y. So y-axis goes up and down. So that's the rise. X-axis goes left to right. That's the run. Now, you can use the formula to try to figure out what the slope is, or we can use a calculator. What would you guys rather do? Use a formula or use a calculator?
I feel like
Okay, I got one vote for calculator. So let's do it the hard way first. So got my data in here. For this, I'm going to need to clear out all of that stuff. So now I've got L1 and L2. And when we look at coordinates like we've got here, where it says 310 and 830, the first number in there is the x value. The second number there is the y value. So we're going from x equals 3 to x equals 8. And then over here, we're going from y equals 10 to y equals 20. Once we've got just those two data points in there, and keep in mind that when I've got these plotted in here, you can see that it's two. You should do it like this, I guess. So 3 and 10 versus a 3 and 10, 8 and 20. Oh, that's a 30, isn't it?
yeah.
So I should probably put the right numbers in. That might help. So 30. So once we've got the right numbers in here, I can go back, hit stat, can go over to calc. And down here we have this thing that says linreg. Hit the enter button here. X is L1. My Y list is L2. My freak list, we don't have one here. And then we can come down here to calculate. I'm going to hit enter. And this is telling me using the equation y equals ax plus b, a equals 4, b equals -2. So what does that actually mean? When we plug these in, to get if we're looking for the slope of that line, we want a. So what's that value? 4. We want to know the equation of the line. It's going to be y equals 4 times x plus a -2, so 4x minus 2. And then we're done. And if I felt a little more comfortable doing it, we could actually look at some other data points. But sometimes I get in trouble for choosing certain points like, hey, let's look at 4 and 20. Because people associate that with something or other. I don't know. So, but anyway, you can plug in whatever numbers you want. So here, plug in the T points. We do go through the same thing. Put in 1, 5, and then 7.7 and 18.1. And then go back to stat, calc, linreg, and it's done. So looking at what we have here, how much other stuff do we have to do? How much more distance was added to the ride going from here to here? Label this. Okay. So if you connect 2 points on the graph in question, blah, 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 with the triangle, it would look something like this. Label the coordinates of the two given points. So this is going to be the 1 and 7.7. This is going to be 5 and 18.1. How much more distance was added to the ride going from here to here, and then label the values on the triangle. So anybody else a little bit confused as to what they mean by that? So what we're looking at here is we've got our right triangle. So this is going to be 1 comma 7.7. This is going to be 5 comma 18.1. And we want to figure out what is the distance from here to here. And I'm going to call that D. Because this is the X direction, I'm going to call that X. Because this is the Y direction, I'm going to call that Y. And then we all remember Pythagorean's theorem, right? A squared plus B squared equals C squared. That's actually the formula that we're going to be using here. A thing that we need to try to figure out, though, is how long is X? What is this coordinate point going to be right here? So if we're looking at X, we know this is a 1. We know that this thing that's right above it is a 5. It's down here. This should be a 5. And we know, and then we have to figure out what is the distance from here to here. Because this is a straight line coming out from here, we know that this is 0.5, then 7.7. What is the difference, or what is the distance when we go from 1 to 5? How many is that? 5 minus 1 is 18.1 minus 7.7 is why we have calculators, right? So 18.1 minus 7.7. So we know that this is going to be 10.4. So now we can plug all these numbers in. 4 squared plus 10.4 squared is going to give us a d squared. So with the calculator, I want 10.4 squared. Since that's the last answer I have on there, I should actually be able to just hit the x squared button here. And it says answer squared. What it's doing is it's actually going to be taking this last number here and squaring it. And then I want to say plus 4 squared. So we now know that this is, so I'll write this down here. D squared is equal to 124.16. So we know what D squared is. What are we actually trying to find? D. How do you go from D squared to D? You take a square root. So if I hit second and then hit that x squared button, by hitting the blue button on here, it gives me access to the square root. And then I want to, the number that I had before, I can now type in 124.16 or hit second again and then hit the negate button. Above that is answer. So it's 11.14 miles if we're talking about this in terms of miles. So to show you all of that. So D is equal to the square root of 124.16, which is equal to 11.14. Then looking at like this number 13 here, it says estimate the distance of a $16 cab ride. So again, if we're using the formula that we had before, you know that we've got cost. So how much money does it cost is 260 per mile plus 510. So according to the problem, we want to know how far can we go if we only have $16 in our pocket. We don't mind, say, not giving the cab driver a tip or anything like that. So we'll say 16 equals 2.6x plus 5.10. I want to get x all by itself. First step here, subtract 510 from both sides. 16 minus 5 is 11. So the added 0.1 is going to be 1090 equals 2.6 times x. Divide both sides by 2.6. And I can now come up with a formula or come up with the value for x. So do that with a graphing calculator. Go about 4.2 miles. Hmm. So if we wanted to try to rearrange this, so if we have y equals mx plus b, we can rearrange this and we would end up getting x equals y minus b divided by m. So if we know how much we can spend, we know what m is, and we know what b is, we can figure out what x is going to be if we rearrange it. So how do I get it there? Subtract b from both sides, so that's the y minus b, and that y minus b equals mx. Divide both sides by m. That gives you the x all by itself. So looking at this, everyone knows that after you buy a car, in most cases, its value decreases as it gets older. Suppose you bought a used car for $15,000. The value has been decreasing by a rate of $2,000 per year since then. Um, so what's the function going to be here? In this case, B is actually going to be $15,000. And because this says decreasing here, M is going to be negative 2,000. So according to this, the value of your car is going to be negative $2,000 per year, plus they're starting with whatever you originally paid for it. Okay. Now, does the rate of depreciation per car actually equal $2,000? Or are they just trying to make that a lot easier on ourselves? What's the big factor that you look for if you're going to be buying a used car? If you see two vehicles that are pretty much the same make and model, but one's got, say, 150,000 miles on it, the other one's got 50,000. Um, Which one of those two cars should be cheaper? 50,000 mile or 150,000 mile? All right. So we should actually be looking at the mileage. There are actual calculators out there for that. Something you need to watch when you're looking at things like this as well is if you take this out far enough, so you can see at year five, the value is $5,000, year six, $3,000, year seven, $1,000, year eight, negative $1,000. What does that actually mean? If the value of your car is negative $1,000, what does that mean? You're supposed to pay someone to take your car from you? Really? Does that ever actually happen? No. So one of the things we have to keep in mind with the models that we're dealing with here is that they might be useful, but only over a certain period of time. After a while, their usefulness will start to diminish based on this type of idea here. The uh, like the first car that I bought, it should cost me about $20,000 to have someone take it away from me. What did I end up doing? I sold it to my brother for 2,000. So you need to make sure that you have the right data and you can actually get things to work properly before you start looking at these sorts of things. So looking at what we have here, so it says finding slope and y-intercept. So this m is the slope, and b is the y-intercept. So again, we can look at a bunch of things here and then try to figure out what's actually going on here. Knowing where a bunch of these problems actually go to. So instead of using the example problem that's in here, um, we can think of this um, kind of like if they're looking at in terms of was it flavored snow cones? And what they've done is they said why. So this is going to be, say, the amount of money made. So the profit is equal to mx plus b. This b here is a startup cost. M is money made per unit sold. If you look at what they have in there, they're trying to combine a bunch of different things that we've been going or dealing with throughout the semester. So if you look at literally everything that's here, what are they trying to do? They're trying to figure out if so like what is profit? Profit is revenue minus cost. So they're looking at this, and when you look at everything on there, they're saying basically, um, and I'm not using this same values that they had in here, but say it's $5,000 to buy the initial set or the initial ice making machine. So that's going to be the startup cost. To figure out what the profit is per unit, they're looking at it and they're saying, well, what if I sell it for, say, $3 a piece minus all the different costs that are dependent upon how many of these things I sell, right? Meaning what? If I if I have an ice making machine and I use enough ice to make, say, 20 of these ice things. So I've got to count for how much ice am I going to use? How much syrup am I going to use? How much is a cup that I actually, or the cone that I actually put all these things into? So they're looking at it as I'm selling it. So revenue is $3 minus, say, 10 cents for the cup, 12 cents for the ice, 5 cents for the flavoring that's on there. Maybe there's a charge for electricity or something like that. All these things that need to be taken into account. And then just to make it easy, let's say it comes out that profit per unit is $1.25. Okay. So we now have Y, which is total profit, is equal to $1.25 times X. So the number of units that I sell minus my startup cost. So minus $5,000. Now, anyone here ever buy food from a food truck? No? Some of us have? Okay. Sorry about this. Now, a couple of the things that when we're talking about a food truck, what they actually have to keep in mind. So if you ever do buy something from a food truck and you walk up to them, they're like, sorry, we're sold out of that. If they sold out in the first hour, that's just bad planning on their part. But if they sold out 20 minutes before they close, that's about as good as you can get when it comes to trying to prepare for all those different meals and all that. But one of the things that they've got to do is they've got to look at what is my startup cost? What is my initial cost going to be? If I'm going to drive my food truck out to wherever, I've got to pay for a couple people to be there. I've got to pay for the propane. I've got to pay for the gas to run the electric generator, to run the deep fryers, blah, 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 blah. I know about how much money I'm going to make per item that I sell. So what they need to do is try to figure out how many units do they need to sell to actually make it worth their while. Just as an example, um, one of the food trucks that I saw, their lobster rolls and nothing but lobster rolls, $25 a piece. Yeah, $25 a piece. Do you think they sell a lot of them? So, where versus say the burger or the barbecue thing where it's say $20 for a plate and you get sides and everything else. You get your choice of meat, choice of side, blah blah blah. So a lot different stuff going on there. But we want to figure out what is this X value if we want to make sure that uh, that we're actually going to make some money. So we need to look at something called a break-even point. What's going to go on there is the break-even point means my profit is going to be zero. So this is giving me an idea of the minimum number of items I need to sell in order to make money. Now I've got our X. What's our formula for figuring out what X is? Right here. So X equals Y minus B divided by M. Plug in our numbers here. What's the Y value? 0 minus B. Um, so in this case, B is 5,000, negative 5,000. Negative times a negative is a what value? Positive, right? Divided by $1.25. So this is going to be 5,000 divided by, sorry, $1.25. So in this case, 5,000 snow cones divided by $1.25 a piece. I need to sell 4,000 of these stupid things before I begin to make money? Do you think if I'm going to something like or if I'm going to have like my own, say, ice cream cart or something like that, do you think I'm going to sell 4,000 of these things, taking my ice cream cart through the neighborhood? Like if I can get in or have set something up so that say I'm outside a big concert venue or something like that. Um, like on what is it, Memorial Day, Detroit Electronic Music Fest. Try and set up something out there. How many people go to D near 100,000? Or last time I checked, it was like 170,000 tickets were sold, something like that. Could I get 4,000 people on a hot summer day being like, hey, I need something cool and refreshing. Um, can I get cherry? I would hope so. So something like that might actually be worth my while. And I'll just try to keep things realistic. Um, there are a couple of different breweries that I've gone to where they try to have all these different food trucks come up. And when they do their math, they might find that in order to make it worth their while, they need to sell 50 items. If it was a big brewery, or if they were, say, parked outside of a Tiger State or a Comerica Park during a Tigers game, could they sell that many items? Oh, hell yeah, and a whole lot more. But for a brewery where they might get 30 customers all day, are those 30 customers each going to buy, say, two different items from this person? Probably not. So what ends up happening is uh, the food trucks will go out there a couple times and then realize that they're not making any money. And then next time the owner of the brewery is like, "Hey, can you come out?" They're like, "No." The last two times I was out there, I lost $150. So if you want to pay me $200, I can be there. That way, I can be basically guaranteed to make some money. And if the brewery owner says, "All right, I'll give you 200, come on out," cool. They're making money. And I will say, in a case like that, let's say we're talking about this person with the ice machine. If the brewery or wherever is going to pay me $200 just to be there, how do I figure out where my break-even point is going to be? Well, it's going to be this $5,000 minus 200. So it's actually going to be $4,800 because they're giving me that extra 200 just to be there. I can see here that they've got a bunch of different topics on here. So here are the like the snow cones. Ooh, so cost of cups plus syrup plus the cost of ice. That's where I was saying, like up here, they're going to charge $3 a piece, and then to figure out what is their profit, it's going to be minus the cost of cups, minus the cost of syrup, minus the cost of ice, and so on. And then they were saying here, I called it a startup cost. They're calling it a fixed cost. So startup costs or fixed costs are basically what? How much you have to spend bare minimum just to be there. So the equipment you need is $5,000. And then if you're going to be a food truck owner, let's say you have to pay another $500 to get the Oakland County food truck food certification or that food server certification thing. So you can actually sell food. That goes into the startup cost. If you're also going to go into say Macomb County and let's say they charge $500 a year, that's another 500 you have to pay. You're going to do that down in Wayne County. It's actually possible that Detroit might charge you $500 and then the rest of Wayne County will charge you another $500. So all of that would go into this startup cost, or as they're actually calling it here, the fixed cost. And you can see here based on the function that they've got. See if I can make that a little bit bigger. Based on the numbers that they actually use, clearly not the ones that I used. Their break-even point is 389 units sold. Once they get there, they start to make money. So if they can sell 500 units, they're going to make $100. Really? That's not what the business end of also influences? So when you're looking at all of these things, again, we have to make sure um, you have to think about everything that goes into here. Suppose you're like after I leave here, I'm actually going to see one of my friends who's a massage therapist. She's now working on her own as an independent contractor. What are her startup costs for this place? Well, how much did it cost her to get in there? Nothing. But um, she did have to buy the massage bed. She did have to buy the sheets put on the massage bed, right? Anyone here ever get a massage where like you're the fifth person to use the sheets and all that? Kind of disgusting, right? Kind of illegal too. So that sort of stuff goes into the startup cost. And she's going to charge, say, $100 per massage, just as an example. And we want to figure out how much money does she make. Or we can look at this a couple different ways. How much money does she make per client that she sees? Or try to figure out how much money does she make per hour that she works. Okay. We could look at it either way. Both would be absolutely valid ways of doing it. Um, but let's say she charges $100 per client. What are some of the things that are going to be costs associated with each one of those clients? Meaning the amount of money she has to spend changes depending on how many clients she has. So it's going to be the number of sheets that she needs to change. She only has one client all day. She only needs to wash what? One set of sheets. If she has five clients all day. She's got to wash five sets of sheets, right? What are some other things that she needs to worry about? The place where she's in right now, they charge, say, $30 per hour. So if she's renting out this room for say 5 hours or something like that, um, and again, if she's got the five clients, there's going to be $30 per hour charge per client. So she's pulling in 100 per client. She's already out 30 for the hourly rent. She's out, I don't know, let's say 50 cents dollar for having to wash these sheets and stuff like that. What are some other things that as a massage therapist she's going to have to deal with on a per client basis? Please tell me there's someone listening who's gotten a massage from someone before. Oil. Hmm? Oil or lotion, yeah. So, um, and with that, do you think she's gonna use a lot more lotion on me than say, or so size of the person does matter a little bit too. Well, you can pretend that everyone's the same size and make it easy. So when you get done with all the math that goes into here, um, she might, or the way that it's set up for her right now, if she works basically full day there on Monday, uh, what is it, what is it, like Wednesday or Thursdays, and then she comes in on Fridays as well. That's all profit for her because her break even point is basically five clients. So she can have her entire Monday filled up. All $100 she gets from every other client on the rest of the days that she's up there. That's pure profit for her. So anyone else here make $100 an hour? Yeah, no, no one. Okay. Well, if she's doing really well for herself at $100 per client on like say Wednesdays and Fridays. Yeah. But what if she only has three clients on Monday? She won't start making money until Wednesday. If she only has two clients today, and let's say she's got to take a Friday off to take her kid to a doctor's office, or she's got to go to the doctor's office. Can she make money when she's at the doctor's office? No. So even though it sounds really, really wonderful, $100 an hour, I'm, I'll do that. But because it's kind of like being a tipped employee, um, it's $100 maximum per hour. Reality is it's probably going to be quite a bit less than that. And when I'm talking about uh, like making $100 an hour, uh, so you can see some of the different questions on here. How much? What's the total cost from selling 400 snow cones? What's the revenue? You could plug all that stuff in. That's a bit of a pain in the butt to do. Um, but just something like to think about. Uh, for me here, to have the privilege of coming in here and torturing you all approximately what, 3 hours a week? Technically, it's well, 4 hours a week ish. But some of you are in the 4 credit hour class, some of you are in the five. I'm getting paid a flat fee of $4,000. And if I wanted to figure out how much I make per hour, got my $4,000. This is going to be a 15 week class, and I uh, work, since most of you don't stick around for office hours afterwards, I don't stick around either. But in case my boss is outside, I work 5 hours a week. So how much do I actually make per hour to come in here and torture all of you? So $4,000. And I could do this, say, divided by 15, and then divide that by five. And I can do it that way. It's only $53 an hour. Is it really worth $53 an hour for me to get up out of bed in the morning to be here? Apparently it is. If I'm teaching up at U of M, $6,000 plus for the class, we'll call it 6,000. Again, it's a 15-week semester, but I'm only expected to work 3 hours per week, which is my teaching, plus the office hours. So technically it should be four. But again, most of my students don't stay for office hours because they, like you, are like, I don't want to listen to this guy any more than I have to. So when I say, well, I'm done for the day, they're like, yeah, we were done 20 minutes ago. Bye. So if I'm looking at what I make per hour here, I can say 60,000 divided by, I can open the parentheses and say 15 times 3, close the parentheses. Now, if I had the choice, would I rather work for $133 an hour or $53 an hour? Mhm. So what's the issue with doing something like this?
Yeah.
I I can accept every single class that's offered to me, but if they don't offer me anything, then how much am I making per hour that semester? And just like trying to be honest with the sort of stuff. So if you do talk with some of your adjunct or some of the other adjunct faculty, at one point there were people that were actually trying to make a living off of being an adjunct instructor. If I could get two classes here, two classes at Macomb, a class or two at Oakland University, class or two down at Wayne or something like that, and keep that going all semester long. Work maybe 25, 30 hours a week, pull in 50, 60 grand. Not bad at all. But uh, college enrollment is down, which means I'm no longer getting 2 classes per semester here. I'm only getting one. Um, at OU, I used to get 2 classes per semester. Now I'll get 1 class per year, maybe. So when we look at the numbers here, that's maximum pay. And because I actually did have my taxes done a while back, the total amount of money I made in 2024 was what, 42,000. Working under 20 hours a week, making 42,000, not bad, but 42,000 kind of isn't getting the bills paid, right? So, yeah, so some of the issues that come up with that. So, to do some of the things here, again, you can see what they're trying to tell you to do with the cells. You have to download or using the tech assignment, which I've got to post on this or post eventually. Okay. We can, which is going to basically give you, come on, like literally all of this stuff here. And it should already be set up so that everything's ready to go. And if I look at this, you can see if I can make this a little bit bigger. You can see the number of snow cones sold, the number of cups used, the cost per cup, how much syrup is used per 100 snow cones, the cost of syrup per ounce, the amount of ice that's used, the cost of the ice, uh, combined supplies. So this should actually be uh, $1. Oh, actually, sorry, the over here the 257 is $1 times 100 plus $4 times 200 allegedly supposed to be something like that. Anyway, you can go in and calculate all this stuff. If you do it correctly, what you end up with is basically this column A is going to be your X value. This net profit here is going to be your L value. You can plug those into your graphing calculator the way that we did with those 2 data points and figure out what the slope of the line is going to be. Or if we already know, in this case, the fixed cost is $245. We know that the net profit is going to equal, um, and you can see here, revenue is $75 per 100 cones. So that means the slope is going to be 75 divided by 100. So 0.75 times X minus 245 because that's a fixed cost. So, and just looking at this, that the cost of the syrup that might actually be considering that it's a 200 or you're going to be using 200 ounces of it, and 200 ounces is going to cost $4, I think. And then for 100 cups, it, it costs $1. So a penny per cup. So, uh, when you look at all this stuff too, you can actually go in and figure out like how much they're actually charging if you needed to. But that's actually about all that we have for 3.2. Already went through how do we make these different plots, showed you how to do that in Excel as well as in uh, with the graphing calculator. So just looking at this, it says to find the y-intercept. That's the value, or that's the b. So here, that's the negative 245. Says find the y-intercept on the graph and explain what it means. In this case, the negative 245 is the startup cost or the fixed cost for buying all the equipment. The x-intercept is the value of x you get when y equals 0. So this is a 389. So what does that represent? That represents how many items you need to sell before you start making money. Then find the slope. Well, you can plug those values in. We've already talked about that. Find the net profit on 150 snow cones. Once you've got the startup cost, once you've got the how much profit you're making per item, you can start doing your calculations and figure all that stuff out. But it's basically using all the ideas that we've already gone through. And again, if we need to graph these, we can do that. We know how to do it in both Excel as well as um, with the graphing calculator. Here, though, we do need to be aware that values we have go from negative 375 to about $600. So if we're going to do this with our graphing calculator, what do we have to do? If we want to get a full idea about what the graph looks like for this particular data set, X-min, so what's the minimum number of items they can sell? 0. What's the largest number that they're looking at on here? 1,000. What's the minimum value that we have? Looking at the profit here, negative 365. We should actually make that say negate 400. What is the largest value that we have in profit? $595. So we should actually make that 600. Then we can graph that, and that's kind of what it's going to look like. But it's still trying to plot the data from the first problem that went through 1 through 9, and then all the way up to 23. So if you look really, really, really closely, that blue blip right there is the data for Metallica's um, album sales and all that. But anyway, that's all I've got for now. Which means you can all go now if you need to. I didn't know most of you already checked out like an hour ago, so thanks for at least pretending to pay attention. And I should say I have found a way